Okay, so video just got disconnected because I moved the camera. These are your fundamental identities. These are your even-odd identities, but we're not going to do the lesson which has sum and difference, and we're not going to do the half angle or double angle, or product to sum, or sum to product. So there are even more identities, but we're going to stick to what we have. And I'll give you a copy of that sheet. So I'm just saying skip sum and difference, etc. Okay. Okay, on the back side, it says these identities, let's see, these should not merely be memorized, but should be known. In fact, minor variations of them are often used, such as solving for one of the trig functions, such as sine squared or cosine squared. In fact, I even saw one question where you're going to change 1 to be sine squared plus cosine squared. So your substitution can work both ways. So you may even have sine squared plus cosine squared equal 1 and change 1 to sine squared plus cosine squared. For this reason, among others, you need to know the relationships between them and be comfortable with variations of them. Okay, so here are your guidelines. It's almost always preferable to start with the more complicated side, the more complicated expression. And you're going to want to rewrite sums or differences of quotients as a single quotient. What that means is get a common denominator. And on the next one it says sometimes rewriting one side in terms of sine and cosine will be the only thing that helps. And the last one, always keep your goal in mind. As you manipulate one side of the equation, you must keep in mind the form of the expression on the other side. Let me show you a little bit about what I mean for that. So on one side you may have something and then equal to secant x plus cosecant x. And you might have to change one side of the equation and you end up with 1 over sine x plus 1 over cosine x. And you keep this side the same. So then this turns into cosecant x plus secant x. And then you're going to have to reverse it to say secant x plus cosecant x. And then equal to secant x plus cosecant x. So in other words, one side is going to stay the same, and you're going to have to change one side to match. So that's just a random example. We'll do more examples in our book work. Okay, I'm going to pause the video to get out the notebook paper. Okay, so again, we're on 7-4, page 474, numbers 3 to 18, 20 to 52, every other even. So number 3, if f of x equal g of x, for every x in the domain, the equation is called an identity. If f of x equals g of x for every x in the domain, the equation is an identity. This is similar to what we talked about in the notes, where it works for every angle or every value of x. Otherwise, it's called conditional. So those would be the blanks if you had this on Math Excel, but do write the whole thing. If f of x equals g of x for every x in the domain, the equation is called an identity. Otherwise, it's a conditional. Like only working for certain values. Only works for certain values. That's what we mean by conditional. Okay, so number 4, we need to write our Pythagorean identities. We have sine squared x plus cosine squared x equal 1. We have tan squared x plus 1 equals secant squared x. And we have cotangent squared x plus 1 equal cosecant squared x. So make sure you write those, because the more you write it, the more you'll get used to using them. And then what we want to do is write another form using the second one. Write another form of the second. And so what we're going to end up doing is moving the secant squared over and moving the 1 to the other side. So we're going to have tangent squared x minus secant squared x equal negative 1. So that's just another form for it. Again, this involves algebra because we're subtracting 1 from both sides and then subtracting another term from both sides. No, we're only going to do one example for that. But like if you solve for cotangent squared, you'd move the 1 over, it'd be cosecant squared minus 1. Yeah, all your combinations. All right. And then number 5, these are, again, examples of even and odd. We have your angle going backwards and forwards. And so what we have are cosine of a negative angle is cosine, and sine of a negative angle is negative sine. And so you need to write that part, which is your even odd. Now, what they want to do is only use cosine. Okay, so in this example, only use cosine. So what they're going to do is bring this over, and you're going to have cosine of negative theta minus cosine theta equals 0.
Is that a negative sign?
Yes, this one is. Yeah. And the reason is because, remember, cosine relates to x and sine relates to y. And so once we change from downstairs to upstairs, it's got to change sign. S-I-G-N. So again, on number 5, you need this, and we're basically putting cosine on the left, and so we get 0 on the right. Cosine of negative theta minus cosine theta equals 0. Number 6, this one has a true-false question, and it's somewhat related to your even-odd, but it's using sine. It has sine of a negative angle plus sine of an angle equals 0. So think about if we move this over, it really would have to be plus, and so it's going to be true. So basically when we get 0 on the right for cosine, it's minus. When we have 0 on the right for sine, it's plus. Okay, number 7. This is another true-false question. And it says it's easiest to multiply. Bless you. It's easiest to multiply both sides by a well-chosen non-zero expression. So that sounds very fancy. It does work sometimes, but unfortunately that's not going to be the best. So it's false. The reason is because you're usually going to substitute. So even though it seemed like that'd be the right answer, multiplying by a well-chosen non-zero sounds very fancy, sounds mathematically correct, it's false. Because usually you want to substitute. Okay? Any questions about that? Okay. Number 8, another true-false question. This one has tangent theta times cosine theta equals sine theta for every theta not equal to 2k plus 1 times pi halves. So first, before we even do the problem, let's think about why they would have some places where it's not defined. The reason is because, remember, tangent has asymptotes, and it's odd multiples of pi halves. So this part is because of the asymptotes. So what we want to do is keep our right side the same, so we have sine, because the only thing you could do with sine is change it to 1 over cosecant, which isn't really going to help us in this case. So what we need to do is change the left side only. And so tangent would be sine over cosine times cosine equals sine. And after that one step, it's easy because your cosines cancel and you just get sine equals sine. You are going to have ones like this where you're going to have to show work. And by the way, it did end up matching up, and so it's true. And you can't just skip from the first step to say sine equals sine. On some of your problems and some of your math excels, they're going to want like intermediate blanks. Like, what do you put in your denominator? What do you put on the side? So that's why you need to show work. So as a quick example, I'm not going to go through this whole problem, but it says establish the identity, and this says write the left side in terms of sine and cosine, simplify, and then which one. So this is pretty typical of what you're going to have to do, and that's why you're going to need to show work. Okay? Okay, so there's number 8. Okay. Just a couple more, and then we'll play that Professor Dave video. Number 9. This one, the directions say rewrite in terms of sine and cosine. That's the directions. You don't have to write that. But what we have are tan theta times cosecant theta. It doesn't say equal to anything. We just need to rewrite it in terms of sine and cosine. So tangent, as you use your quotient identity, tangent is sine over cosine. So again, like we said in the notes, you need to get familiar with just changing tan to sine over cosine. And then cosecant is the reciprocal of sine, so we say times 1 over sine. And that's where these would cancel, and so you end up with 1 over cosine. Now, since the directions said rewrite in terms of sine and cosine, that's your answer. Don't change to equal to secant theta. Even though 1 over cosine is secant, we want to rewrite it in terms of sine and cosine. So you got to know when to stop. Any questions? Okay, and then the other one kind of like that is number 10. Cotan theta times secant theta. So cotan is the opposite or flipped tangent, and so we're going to put cosine over sine. Cosine over sine times, and then secant is 1 over cosine. And so these cancel. So we get 1 over sine. And again, don't change it to cosecant. Okay, well that's a good introduction. And now we'll do the Professor Dave. And we'll start the next time with number 11.